This is the Amp Hour Podcast. Released September 15th, 2019. Episode 458. An interview with Ken Burns. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Ken Burns with Tiny Circuits.
Hey Ken, how you doing?
Oh, pretty good, Chris. Good to talk to you again.
Yeah, back in Ohio, my old stomping grounds, or south of my old stomping grounds, I suppose.
A little bit, but still northeast Ohio, just south of Cleveland. So
northeast Ohio. That's right. Yeah, the NEO. I remember there was a when I lived there, there was like a not accelerator, but it was like a booster club for like technology in NEO. I don't remember what it's called or if it's still around, but NEO everything.
There's a team NEO now, and I don't know, they like that acronym because it kind of encompasses all of what they consider Northeast Ohio, which is Cleveland, Akron, Youngstown.
Yep.
Yeah, but I'm here.
Nice. Well, it's great. It's great. And so we never worked together directly, but I actually used to work with some of your former coworkers at your old job when you were a consultant engineer at Avid.
Yeah, and actually, again, the world out here is relatively small, and so engineers, again, you don't want to burn any bridges in this area because you're going to run across the same people that you met earlier on in life, and so, especially in electrical engineering or firmware engineering, it's a relatively small community, so it doesn't take long in a career before you start kind of overlapping. And so, like you said, I worked at a place called Avid, and so we had a number of engineers there that worked really at all different places, and so it's just kind of interesting to see how things mingle together. Certainly in this area.
Yeah. And so, well, let's hear. So we're going to work all the way up first. You said you're from Tiny Circuits. We'll definitely talk about that. You have a Kickstarter coming up. We'll definitely talk about that too. So where'd you get started? I mean, like maybe even before. CIA too.
I figured you'd see that one now.
Yeah. So you have a long and storied background in hardware before you became an entrepreneur and doing hardware. How did you get to where you are today?
Oh, I think maybe I have the standard engineer, techie type background in terms of childhood. So I was kind of had the
Legos and taking stuff apart.
Exactly, the taking stuff apart, playing with Legos and playing with computers. So at a very early age, kind of playing with computers. And actually, I'm a bit older than you, so I remember when the Apple II first came out, and so we actually didn't have a computer, so I had to go to the local library when I was 5 or 6 and have to sign up for 15-minute increments to play on an Apple II, and then we eventually got a Commodore 64 was our first computer, I think in '83, and so I was about like 8 years old, and so remember kind of cutting my teeth on that in terms of programming basic and just playing around and playing games. And so my brother and my brother's a mechanical engineer. And so we were kind of, big computer geeks, I think, which is common with a lot of the listeners here. Just kind of always, navigated or was attracted to math and science. And so certainly through high school, I just kind of knew that engineering was where I wanted to go. And so I enrolled in electrical engineering. And so it's kind of a toss up between that or mechanical. But I was really more attracted to kind of computers and just fascinated with how they worked. And so it really kind of started it in terms of really want to figure out how these things work and, hopefully work in that field just because, again, just had such a love for computers. And so went to the University of Akron for electrical engineering.
Nice. That's great. Mm-hmm. And, kind of, you've been in the Midwest the whole time. So has that, or not the whole time, but the whole time? Yeah. Sorry.
I was in DC for a little bit. Yeah.
Scrolling the page here, the old LinkedIn page. So why, I mean, I guess I get this question too. Why the Midwest? Why not move to California? That's what Dave always asked me. Like, why not go where more hardware is?
Well, why don't they move here?
That's a great question, Ken. We should start an NEO.
Sell the Midwest, yes.
No, NEO right here. Here we go.
Well, you moved from here, though, Chris. You moved to Chicago, right?
There was reasons. I had reasons, yeah.
Yeah, I mean, it's still Midwest.
I'm still Midwest.
I'll give you a pass. At least you didn't go to the Valley or something.
It's a little bit less Rust Belt than my upbringing was. Cleveland and Buffalo and Pittsburgh is quite a bit of rust in there. But, now I've got skyscrapers and big city.
So there's skyscrapers in Cleveland. They're rusty though. Yeah. So yeah, I guess the term for the area is certainly the Rust Belt, and so it's got a very industrial past. And actually, right now, where our office is, I'm in an old rubber factory on the 5th floor of a big, huge brick building.
Yeah, that place. We'll definitely talk about that too, because that's a cool spot.
It's a very cool spot, and so, I think there's this fallacy to believe that all the real jobs are on the coast, and if you want to do anything in technology or certainly high tech, you've got to move to California, Boston, or something like that, or Austin. And it's really not the case. And certainly in our case, in this area, like some of the places you worked at, it's definitely an industrial focus, I'd say, is kind of the strength. And if you look at a lot of the companies that are either headquartered here or have big presences here, they tend to be kind of almost the old guard of technology, you might say.
Yeah, I think so.
And so there's certainly, I worked for a little bit as an intern at Rockwell Automation, which was the old Allen Bradley, was the group I worked in. But again, you see these things for big industrial control facilities, but they really were doing quite a bit of high tech development. And again, it doesn't have to be the fanciest consumer Fitbit type thing that you're working on to kind of, get your chops going. And so,
I think that kind of stuff is it's like running so we had John Davis on too, who you may know. I don't know if you know John.
No, I don't.
But also from Ohio, and he does a lot of industrial stuff too. And you just hear about like these things that are actually controlling plants and out in the world and making things go. Like just like Detroit is for cars, and the Valley's for consumer. It's just kind of like it sounds like it's just kind of concentrated in specific areas.
And then too, you get these startups out of the Valley. And again, I'm not putting down the Valley, but they'll come out with something of some way they're going to completely change and disrupt factory automation and whatnot, without realizing that there's a lot of big players out there that are doing a lot of things. And again, they might not be as flashy and as showy, but the engineering talent, I say, at a number of these places is definitely on par with potentially startups. I also think, again, startups generally, I don't want to say they have ageism, but certainly it seems to attract a younger engineer.
Yeah.
And I think some of it's due to the lifestyle, the amount of work hours and whatnot. Whereas certainly around here, as a young engineer, I think it was really beneficial to be able to work with people that have worked 20 or 30 years in industry and kind of learn the old ways of doing things. And understanding that was really great to have that kind of mentorship as you grow up, as opposed to being thrown in a startup where everybody's just freshly out of college and has never designed a product before. Where I was working with people that you had worked on billion-dollar industrial type facilities, were working on consumer products and all sorts of different things that have done 20, 30 products before. And so being able to kind of go through that almost boot camp when I was at Avid was really kind of cool in terms of learning how to design product.
Yeah, definitely. And I'll do a callback to another previous guest too, Todd Bailey. I remember I talked to him back on one of his previous jobs. He actually specifically chose a job just for working with a couple graybeards there. And I totally endorse that method of like going to find mentorship and going to find, people that have been there and done that. I think the risk is always if you get jaded too early, like obviously there's a lot of grumpy happening with the graybeards as well. But I think in terms of like the actual learning opportunities, I'm going through that right now. I'm actually seeking out, I talked about it last week on the show, I think. I'm seeking out tutors right now where I'm just going to hire people to try and replicate that experience. And people that work in companies like you're talking about, you get that, not for free, you get it, as part of your job though. And it's a great resource.
Yeah, it really is. And part of my job now, we deal very closely with a lot of universities, again, kind of in the maker realm, not only our customer base, but then also we have a number of interns. We had 4 engineering interns in this summer, and marketing interns and others. And I try to mentor them in some ways to say, hey, the first few years of your career, when you actually get out of school, that you want to go somewhere where you're going to learn as much as possible and kind of in what you want to do. And we've had some, and again, they're kind of chasing the money. And so maybe they take a job that they don't really want to do, but it's got great benefits or whatnot. I'm like, you're 22 or 23.
Right. Your costs
you're
are low.
not married. You got very low cost. You're basically lived with your parents through college. Go somewhere, and you might be making 5 or 10K less than maybe somewhere else, but you could potentially learn a lot of things and really, in 5 years' time or 3 or 4 years' time, make that leap, and then at that point start caring about the money. But it's really those first few years that are super critical. And again, with engineering, if you take a job, let's say you go into sustaining engineering or something like that, after a few years, you're basically that long term. You can't really, it's really hard to do a career change. So if you want to get into design or firmware and you've done something else for 10 years, either you're going to have to take a big, huge pay cut, or most companies probably won't even consider you. So to those young engineers, just kind of try to soak up as much as you can from, again, the graybeards, and don't chase the money until later. Or never, in my case. So.
Well, you do what you can. Well, and you mentioned another thing at Avid though too, and you'd kind of said that, I think you said like replicating the same thing over and over again, or like getting lots of iterations on designs, right? You had mentioned people had done, tens or hundreds of designs and learning from them, but then kind of doing it yourself. Mm-hmm. And that's something you were able to do when you worked at Avid, which was a design house, effectively. It was like a for-hire house. Could you explain what that is real quick?
Yeah, so Avid, it's actually Avnet now, Avnet Design Services. I believe they changed their name too. I
heard about that.
And changed hands a couple times.
Yeah, I think it was around the same time wasn't it around the same time that they bought Eagle, or someone bought Eagle and then they sold it to Element 14 bought them. Yeah, that's right.
Yeah, so they were owned by who's the big company behind like Element 14 in the UK? Premier Farnell.
Oh yeah.
So
Farnell,
originally they're the ones that bought them, and then they got bought out by Avnet.
Right. Yep.
And it sounds like it's actually going pretty well. I still keep in touch with a number of the people there, and but yeah, so in my day, it was privately owned. So there's a single owner that owned the place. And again, he was an engineer. So it was really great from that standpoint. And it was a relatively small shop. When I started there, I think in 2002 or 2003. There were only 8 or 9 engineers. And there was also a PCB CAD group. And that's really how the company was founded. And so they were just basically doing, printed circuit board design services for other people. And then in I believe the late 90s, they brought in my old boss, Rick Benson, who actually worked where you used to work, ABB.
That's right. Yep.
And Rick kind of started up the engineering group. And so when they hired me, I was probably the youngest person they had hired. So I was probably 28 or 29 when I started there. Because again, it was older people. And then by the time I left, they were up to about 50 people. And so about 25 engineers. And so basically we were just an extension of different companies' engineering departments. And so, or anywhere from startups, so if somebody comes with an idea on a napkin and we would do the electronic design for them, or up to dealing with like Fortune 50 companies where they need additional engineering resources for a particular job, or they just want to outsource it. And so the great thing about that place was you generally did relatively short jobs. So it wasn't like working at a big company where you're on one project for years at a time and don't really get any exposure to anything else. Here we're doing things from military electronics to consumer electronics to medical type stuff, or industrial, which I spent a lot of time on. And so just kind of jumping between those things, you really learn a lot of techniques that might be very common in an industrial system, but you wouldn't see in a consumer type system. So you get that overlap of these different areas of expertise.
Why did you put in a 200 volt protection diode, Ken?
Yeah, exactly.
It's bigger than the microprocessor.
And again, so some of those industrial guys or automotive people, when they go to consumer, when your bill of materials cost is more than what they want to sell the product for.
Right.
And again, you do run into that again with some of those industrial type people where they're over design things. It's like, no, cost is the driver here. And so it's kind of good to jump back and forth between all those different projects. Now, any one project, when I first started there, would maybe be a few months, and you might be doing 2 or 3 different projects at once. And so any given day, you might work one day on one project, the next day on something else, or you're splitting hours. And so just, again, that exposure. And like you said, the graybeards there, you had people that had worked in motor control for 20, 30 years, or, industrial electronics at, a number of companies in the area. And so just getting that kind of again, mentorship, where you've got a question and you can go to somebody that knows exactly what to do, and they teach you why you do it that way. And hopefully they do it with a smile and not,
right. Not a grumpy face.
Not a grumpy face, but in general, that place is extremely collaborative. And so I look back on that time very fondly. And again, I worked on probably 50 different products there,
Wow.
most that went to production. And so again, kind of, again, I wasn't the sole engineer in any of those products necessarily, on some of the smaller ones maybe. But again, just having that exposure to all these different design teams and then working with these outside companies to see, okay, if they're manufacturing in China or they're manufacturing here in the States or they have their own in-house manufacturing, just getting exposure to that world as well of dealing with outside contract manufacturers and kind of learning how do you actually take, this prototype that you have on your desk, and making it so you can actually produce 100,000 of them.
Yeah, that's right. Yeah. Mm-hmm. Well, the last thing I want to ask you about Avid was about about Wireless Heart, just because I think that's an interesting footnote. Like you were working on the standard there, but how did you? First off, what is it, and then how did you get involved with it?
So Wireless Heart is a wireless sensor network, similar to, let's say, a Zigbee. And actually, at the time, and actually to move back a little bit further, Heart is a communication protocol to communicate with what people might see as like old school type electronics in
4
industrial.
to 20 sensors are not like are not super hip. You don't see the kids putting those.
But
in
it's actually, once you get into it, it's actually somewhat hip. I mean, it's like, oh, this is really cool. I see why they do it this way. So yeah, these are basically 4 to 20 milliamp type devices, and Heart, I believe, was developed by Rosemount, which is now Emerson, back in the 70s or 80s. It's a FSK signal that you can communicate with these instruments, and so it's used in, let's say, an oil refinery for someone to go out and calibrate a temperature transmitter or pressure devices to measure these big things in again, these process control plants or industrial control plants. And so Heart had been going for a number of years, and people were using it, and it's still extremely prevalent. And even with newer digital field buses, Profi buses, and Foundation field bus and things like that, Heart still had a huge chunk of the market. Because again, these sorts of plants, they don't upgrade instruments every year.
That's right.
Things are installed for 20, 30 years. Easily. And also kind of the mindset of a lot of the operators in place is they know a certain technology and they're not changing because it's a risk. And again, if you're operating a $1 billion oil refinery, you don't take risks usually. And so I worked on a number of Heart interface devices. And so one of our key customers at Avid was a company called MacTech. And actually our owner at Avid, who was a part owner of MacTech as well. And it was basically a single man company, very small company that just made Heart modems. And so these were basically just something you hook up to a laptop that would let you communicate with the Heart device. And so you could use a PC application. And at the time, it was relatively novel. This is the mid 90s. Normally you had to have like this big, expensive field communicator and go out. And now you could use laptops. And so that was kind of how the company got started in the 90s. And they did extremely well. And then by the mid 2000s, there's kind of a push among all these companies involved in the Heart Foundation, people like Honeywell and Emerson and ABB, these big companies in industrial automation, to create a wireless version. And so MacTech wanted to play a role in that, and the owner was not technical. And so I was brought on, through Avid as kind of their technical representative. And so it was really quite cool that I got to go around the world many, many times to these working group meetings over a 5 or 6 year period. And we typically had 3 to 6 meetings a year, usually one in Asia, one in Europe, and one in the US. And got to kind of see the behind the scenes of standards wars in a way. And so you see different companies. Right. And again, I represented a one-person company. And you've got these big $1 billion guys in the room.
You had a ton of sway, though, right?
Oh, yeah, definitely a lot of sway. Like, so a lot of it's kind of sitting back.
If that's your real name.
Yeah, and these big companies all had kind of their thing that they were pushing for. Because, again, this was not done in a vacuum. Everybody kind of wanted to make their thing the standard. And eventually it did become standardized, and it's based on 802.15.4, so very similar to Zigbee. And actually Dust Networks, which was again, Silicon Valley startup that I think learned a lot through this process. I think they thought they knew more than they did, but they wanted to get into industrial automation. And
they got bought by Linear Tech, or no?
They did.
Was that?
And they still make their chips, and they're very good chips.
Okay.
And I really like working with those guys. But again, it's kind of interesting to see the Silicon Valley startup kind of come into this, again, behemoth fight between all these big players. But again, eventually that's what it became. And it actually changed it quite a bit from the original Dust protocol to make it more fit into the HART. And so the product I worked on was called the Wireless HART Adapter. And so this was a device that would communicate wireless HART to wired HART. And so you could put this on, one of these old 4-20 instruments, and actually you could get rid of the 4-20 loop if you wanted, and it would communicate back over the wireless HART network. And so the network, again, is a mesh network, uses a time synchronization. And so you could get very low power at each node. And so
I remember seeing that for like scheduling of like when the packets were being sent on the Dust network thing.
Yeah, everything is scheduled. And so let's say you have a neighbor node that you're communicating with. You basically have a negotiated time that you're going to wake up and communicate with each other. And the entire network is done that way. And there's a network manager that basically schedules that to make it efficient. And then there's redundant routes and all that kind of fun stuff. The problem with that sort of network is you can't really do asynchronous communication very well. So if you have like a sensor node out there and you want to report back data, let's say a light switch in like a Zigbee type network, you can flip the switch and it might be a couple seconds before you're actually scheduled to wake up to send that data. Right. But in the case of a sensor network, it actually works really well, where you're just reading temperature on like...
Right. And they were reporting tenths of an hour or every half hour.
You could schedule it to go actually under a second. But again, that affects power consumption. But big players like Emerson, Honeywell, ABB, they've come out with wireless HART devices, and again, we brought our product to the market, and then that company, MagTech, actually got bought by Pepperl and Fuchs. Maybe
another name that I never knew before I got into the
exactly.
Space.
They're a big industrial company based in Germany, and actually they have a big representation here in Northeast Ohio as well. So they bought them out, but again, it's kind of cool. Again, just to see. As a relatively young engineer, I think I started to go to those meetings when I was in my late 20s. Got to go to about 20 different countries and interact with engineers from around the world, and just see kind of behind this how the sausage is being made, which isn't always pretty, but it's a lot of fun.
I always wonder about that. I don't think we've had anyone on the show before that's done like it was an industry standard, but it was a standard, right? I mean, it became a standard.
Yeah, and actually, there's an ANSI version of it, and I think an IEC version of it.
Okay.
So it's a standard, but then there are also competing standards. There's something called ISA 100 that was out, and again, it was an interesting experience. And again, I'd say in the early days, I basically sat in the room and kind of listened to the fights. But then once we actually got things kind of settled down and chose the technology, I was kind of involved in the physical layer side of it, and then also some of the application layer stuff to define, how these devices actually communicate, specifically like the adapter type things I was working on.
Oh, that's great. That's great.
Yeah, it
was so exciting that you went running from the entire industry.
Yeah, so I
said,
quit.
You know what?
After that,
I'm going to go and build circuit boards instead.
Yeah. And
so what was the build up to you doing that? Because that was a big thing.
It was a big thing. Yeah. So basically the reason there was I always kind of had this bug to kind of start a company. And so even in the mid 2000s, I was tinkering with ideas of different things to do. I was getting involved with a lot of these industrial companies, particularly like through the wireless HART thing. And also a lot of my big focus I did was mostly embedded software, particularly when I was at Avid. And so certainly I did hardware design, but primarily there I did embedded software. And so I was working with all sorts of, again, from consumer to these industrial type products. And so I was kind of taking the idea of the wireless HART, that you have these big 4-20 old school devices that potentially cost anywhere from $500 to many thousands of dollars, but they're extremely simple to communicate with. I mean, extremely simple. You can hook up to one of these things and send one or two commands, and it tells you exactly what it is. I'm a temperature sensor. I'm reporting in degrees Celsius, and it's 47.2 degrees. And I just kind of thought, wouldn't that be really cool for an embedded type sensor? And so originally I started out, let's take that same basic idea and make like a small, simple little sensor bus. You can connect up to sensors. Maybe you can get these things certified to some spec, and they sell these, and potentially gets embedded into a product, and each would have a little processor. like a little ATtiny or something, like a little sub $1 processor, and you could have calibration data in there and do all this kind of fun stuff and be able to sell these things extremely cheaply, but it'd basically be a smart sensor platform. And so that was the original thought. I'm like, oh, people are going to love this and it's going to be so great and change the world. And then started digging a little bit into it. And I'm like, I don't know if this is really going to sell. And then kind of decided I needed some sort of processing platform because I needed to communicate with these little smart sensors I'm working on. And at the time, Arduino was starting to become popular. And the whole open source.
So what is this time frame? I wanted to get that in there.
This is like the late 2000s.
Okay, this is when you started thinking about it, you're saying.
This is when I started thinking about and tinkering around with it.
Yeah.
So again, Arduino started to become extremely well known. So I'm like, well, I'm not going to reinvent the wheel. I don't want to. Again, I was a firmware engineer, but I don't want to do firmware because I understand how expensive firmware is to design and do. So why don't we kind of leverage open source as much as possible? And so I also knew I needed it really small because I wanted these things to basically be embedded into other products. And so I'm like, okay, I'm going to make a small Arduino. And that's kind of how that started. And then completely went away from the whole smart sensor industrial type idea of, hey, let's just make a small Arduino platform. I mean, there's other ones out there, but you can't stack things together. And so
I guess these days it's so common that I feel like we have to kind of do a callback almost to when it
so this is before Feathers, and basically the Arduino Pro and Pro Mini or Nanos were the only things out, so you had to solder. Again, this is
and you were looking at it as like you wanted to make it easier to snap things together, you're saying.
Exactly. Let's make it as small as possible. And so the form factor I came up with it's basically 20 by 20 millimeters, so it's about the size of a US quarter or euro. And they just stack together, and it works exactly like a standard Arduino. All the shield signals are supported. And again, you can snap them together and just prototype things extremely quickly or create your project extremely quickly. And so that was the original idea that I went to market with, and again, I just did this all in my bedroom in my house. I didn't know if I thought eventually this might become a business. I hoped it would. That was really I didn't go into it just as a hobby. I really did want it to be a business. But again, I also had that thought about maybe only 2 people out there actually want this thing. I don't know. I showed it to people at local hackerspaces and whatnot, and showed it online. And there's an interest, but I'm like, are they actually going to pay for it? You don't really know until you go for it. And so,
I remember like seeing it the first time and thinking like, okay, it's tiny, it's an Arduino, that's cool. These are all good things. But then I remember like thinking, well, why wouldn't someone just go and build their own thing? And I think my mistake there was thinking as a hardware person.
Yeah, right? Everybody's just going to build their own thing.
Why wouldn't you just go solder stuff together? And what you're saying is I'm not the target market for this thing. I'm guessing it was all software people, right?
Yeah, and again, I think the standard maker, when you're doing something of this scale, you're dealing with very small surface mount components, and so it's kind of outside the realm of a lot of guys just working out of their house. Now it's actually gotten better. I mean, you can get stencils and circuit boards for almost nothing, it seems like. And so if you haven't done surface mount soldering out there, I'd definitely encourage it. It's a lot of fun. But again, that was the idea of what can we get super small that's really easy to use. And also from the hardware standpoint, if you just need something very quickly, this was a nice, attractive thing. I mean, something else I worked on at Avid, we did a lot of very quick prototypes for a number of companies where we had to basically do like a looks like type prototype where you put something together, it has to do some function very quickly. And basically you had to get a bunch of development boards. You go to DigiKey and buy like a microchip development board and then some other sensor board, and you got this whole huge claptrap, and it's going to break
like $200 if each too.
And it's not cheap at all. And so it's like, why isn't there like a standard way to just connect these things? And then Arduino came out, and there's that. But I'm like, this is pretty big. Just get these shields that kind of stack together. Or before Arduino, like all these different companies would have similar things, whether it's Microchip or Atmel or Renesas or who knows what, would have these development boards with these add-ons, and they're all $50 each. And it wouldn't have the sensor you actually want. So then you have to get a development board from the sensor manufacturer and then wire it up. And so again, that was kind of the mindset of just make this as easy as possible to hook up different components. And so that was the original inspiration for it.
Nice. So how did that first? So you've done how many Kickstarters now?
We've done 3, and we just launched a 4th a few days ago. So the first one was for the Tiny Arduino, is what we called it. I got a little crap for calling it Duino, even though it's like everybody does that. I'm like, okay. So as the Tiny Duino platform, we had a goal of 10,000. And again, I should say I have a goal because it was just myself at the time. And it actually did close to 110. And so at that point, it's like, okay, there's actually potentially a business here. And then I kind of went down the dark path of doing manufacturing and all that kind of stuff, which is a whole fun discussion. So
yeah, we'll definitely talk about that.
So it did really well. And again,
and also this is early Kickstarter too, right? I mean, this was not.
It was. I mean, there were other things too, and it kind of. Although I'm good friends with him, or somewhat friends with him now, and we actually worked on it. The DigiSpark, which was a similar thing, a small Arduino compatible platform. Actually used an ATtiny, just plugged into a USB port, under $10. That came out a month or two. So I was about to launch. I was working on the Kickstarter. That came out and did like 350K.
Oh my God!
I'm like, oh, they stole our thunder. But I'm like, I eventually convinced myself. I'm like, it's quite a bit different. I talked with Eric, who owned it, and then we actually ended up manufacturing the DigiSpark Pro here, which is kind of a unique thing. Again, it's a small world. Everybody overlaps. But so there were some big success stories on Kickstarter at that time. But yeah, it's still very early days. If you look at the original video for that, it's something I shot myself. I'm not a video guy at all. I shot that in my spare bedroom of our house. And I mean, it looks rough, but it's definitely that kind of that personalized touch of, okay, here's this guy doing this. I don't think you could do that now. I think too many people have been burned with Kickstarters to trust that here's just a guy working in his house and I'm going to give him money and he's definitely going to deliver. Again, I think there's a lot more optimism back then. This is 2012, whereas now I think just so many people have been burned with bad Kickstarters or crowdfunding campaigns that it has to be a lot more polished, and we kind of have to sell ourselves a lot better that, hey, we can actually pull this thing off.
Right. Well, having a track record now helps too, I think.
Yeah, it definitely does. So I think that fear is gone, at least. And again, we have a number of happy customers and a track record of shipping, I think, a few 100,000 boards now. So yeah, again, that's nice. But at the time, it was kind of scary. And so I guess to segue into something I think you're going to ask. So we decided, and I had a kind of a stretch goal at the time, which is a thing they do on Kickstarters. Although I don't think we're going to do any now. But if we hit 100,000, I said we're going to do manufacturing here locally in Ohio, in Akron, and we're going to do it ourselves. And I kind of put that stake in the ground.
I'm going to stop you right there.
Yeah,
that's a big leap. That's
It is.
$100,001, and I pressed buy on eBay on the reflow oven that I've been looking at.
And that was kind of again, I had that mindset because I've known of other local small companies that have done it, and they're doing, I guess, similar sorts of things. There's a company called Dimension Engineering that makes smaller robot controllers. They're using like RC cars and different things. And so I knew them, and they had a pick and place line. And that was kind of an inspiration in a way. I'm like, hey, if these guys are doing it, why can't I do it?
Did you see the tears streaking down their face every day? I mean, I don't know.
Yeah, I think I came in a little late after they were a bit established. And I didn't see the early days.
Yeah, exactly.
And so, again, my background at Avid and other places was a design engineer, not manufacturing. And we worked with outside contract manufacturers. I'm like, okay, we send it to these guys and they build us a board.
Right. They send it back and it's done.
And they send it back. Here? And the interface I had with those companies was relatively minor. And occasionally I go to CMs and see their lines. I'm like, oh, this is really cool. I want these machines. This is so cool.
Right. Robots are cool.
Robots, yeah. And again, thought it would be easier than it is. Manufacturing production is much more difficult, kids. Let's say it is not for the fan of heart. And so
that's right. So first off, what kind of equipment did you decide to buy? How did you, so you're coming in completely fresh? Did you talk to people?
Completely fresh. And so,
okay, so you're basically doing research online, like that level of fresh?
Yeah. For a year I had been, because this is kind of the dream. I wanted to do this. So I was looking on eBay for pick and place machines and reflow ovens and all that kind of stuff.
Let me ask though, I don't need details on whether or not it was, okay, but like, was this an escape as well? I mean, was this like, I need to get out of my old job?
I think there was some of that. I think I've
made some crazy plans to get out of old jobs, at least in my head. I just didn't follow through on them,
There was certainly that. I mean, I had been at Avid for 10 years at that point, at the time I finally left. And so I think it was also because I was working with startup companies a lot. I worked with the company MacTech, which is one guy that started on his own. and he went out and he was making very good revenue per year. I saw what he's selling these things for in the industrial market and the margins he was making. I'm like, if this guy's doing it, not that he's a great guy, but I'm just saying.
Was he manufacturing though, or no?
No, he completely outsourced. He was strictly, he's basically in sales.
Yeah.
Not technical at all.
You never see people dreaming about going into sales.
No, but again, so he went into a manufacturing business. He used to be at Rockwell.
I could call people all the time.
Yeah. Yeah, I don't dream about going into sales at all.
Yeah, right.
But so it kind of had that dream for a while. Again, looking at pick and place machines and all that kind of stuff online. So once it actually, I think even before it hit 100,000, I think I actually ordered the equipment. And so relatively quickly, as a 4-week campaign, I think 2 weeks in, I went out with my former coworker and friend, Roy, who owns a small electronics consulting firm. So he worked with me at Avid. He kind of spun off and did his own thing, but he needed space because again, he's just working out of his house. And so that's kind of when we found our original space here in this old rubber factory. It was really cheap. I'm like, okay, got a space lined up. I'm going to get some machinery. And so did a lot of research online. Again, I've been doing it for a long time. So I contacted a company that basically sells refurbished SMT equipment.
I would like to just take a quick pause.
Yes.
Do you remember earlier in the episode when you were talking about startup companies coming in and talking about
how easy these things are?
Know what they're going to do and everything's going to be fine. And oh, man.
Oh, believe me, the irony is
perfect book ending. Thank you, Ken. Thank you so much.
It was... in a lot of ways it was dumb, but on the other side it wouldn't work if we didn't do it that way, because again, as part of the original Kickstarter, we raised 110,000, but we had to ship an insane amount of boards. Some of these boards were just a couple bucks each, and again, because they're so small and they might only have a few components on it, and a lot of the things were relatively low volume, and with the outside contract manufacturers, it's all about volume. So if you have one product you're launching on Kickstarter, do not manufacture it yourself. If you're doing a million different development boards, you're kind of stuck in a way, unless you've got huge volumes. But some of the things we're making 50 of, and in contract manufacturing, it's all about the setup charges and whatnot. So the setup charges alone would be more per board than what we can even sell it for. So it could be 20 or 30 bucks just to set the machine up if you amortize it across how many you're making.
Well, you were also amortizing you, though.
yeah, certainly the design. And actually, the design was one thing, but in the production world, the hours of labor actually putting these things together was significantly more than the design by far.
Yeah.
So there was that. I like to say we raised, because a lot of people this year 110,000, like, oh, that's great, that's a lot of money. And
you're rich.
I'm like, we only lost like 50 grand after that. It only cost us about 160, 170 to actually ship all that product. But
oh my god,
it got us started.
But it's like seed money at that point, right? I mean, that's effectively what it was.
Yeah, we've done,
and it worked in that way, because it also doesn't work like that for a lot of people.
That's true. And so I think one thing, at least I did right on that first Kickstarter, was that really everything was done design wise. And a lot of people that do Kickstarters screw this up, where they use the money to finish the design, and then they run into problems, and it costs more than they expected, and then they don't have enough to actually manufacture it. Not to mention they usually run into manufacturing problems too that they don't understand, which we certainly did. So we ran into manufacturing problems mostly, not in the design. So the good thing was, again, I had enough experience doing electronics that I kept it extremely simple. Each board was relatively, the Max board was probably the main processor that had maybe 20, 25 parts on it. So nothing was very hard. So if one failed, you could usually figure it out pretty quickly. And if you had to scrap something, really didn't cost that much, as opposed to if you had a big board that has 1,000 components on it, if you screw that up, it's a lot of money. Forget what we're talking about. I'm just getting scared now about the old days.
I know. Yeah, you got some flashbacks here. That's cool. So quickly, let's step back to the construction of these things. So what is on board? So what is a sample stack up of these different boards that you might have, and then we'll talk about how you actually manufacture them.
Yeah, so typically in our system, there's a processor board. So originally we called it Tiny Arduino. It was basically an Arduino Uno just shrunk down. So it was a Atmega 328p processor. And then separately, we had a USB, and we call them Tiny Shields. Again, everything's tiny. Great That's an engineer marketing for you. We just put Tiny in front of everything. And so instead of Arduino shields, we had Tiny shields. And so we had a USB Tiny shield, and then you could add, let's say, GPS or Wi-Fi or different things to that stack. So one of the early things we did, I made a GPS cat tracker for a cat. It was actually in Make Magazine years ago. So it was a SD card and GPS module, and you could put it in a Tic Tac container because it's so small. And that actually, we had a bunch of people bought those and made that as a kit. But again, most of these boards are relatively simple. And so, like, again, the processor board might have 20, 25 components. Nowadays, we've got like an Arduino Zero based processor board that has a USB and lithium battery and everything, lithium battery charging built in.
Right. That's
so it makes it much more compact. And then we have one with the actual OLED screen as well that has the processor and everything in it. So you can make little watches and whatnot. But yeah, again, most of our standard boards are relatively simple from an electronic standpoint. And again, that's good too from a lot of our users because everything we do is open source. So they, if they're a more commercial user, they might want to actually take that design and then integrate it into something they're designing. And so all that stuff's published against standard open source type situation. But again,
that's great.
It's easy enough in some cases that somebody could then take that and manufacture it if they want to like adjust something for their needs. And people have done that. It's not insanely complex where only we can make it.
Yeah. So, okay. So you had a high mix of your products, right? So you had, let's just say 20 boards. I don't know what it actually was.
It's something like
that. So you had 20 different boards, but then what was your mix of the parts that were on those boards? So like, mostly because I'm wondering how many, you're starting from scratch. You are having to buy a reflow oven, but then you also have to buy a pick and place and then all the feeders, which is always the restrictive thing. So how many feeders did you need for all that manufacturing?
We didn't need that many. We actually got a lot more feeders than we needed. And one of the reasons for that was we bought used. And again, I'd recommend anyone, if you're going to get into this, and I'm not saying do, buy a used machine. There are new machines that are prohibitively expensive, and even the low one. And granted, there's these new like Chinese ones on eBay and whatnot that a lot of people are kind of getting into. And that might be a good thing when you're only paying a couple grand. But like, there's these machines, let's say Mancorp in different places that Adafruit and people used early on. And it might be a $30,000 machine. And then each feeder is $500. And so now you're up at $50,000 just for a machine that frankly, pick and place machines, at least the real industrial ones are used to make big volumes of boards. They're designed to last a long, long time. They're like 20, 25 years of service is not uncommon on some of these type of situations. So we bought a machine that was from 1996. So at the time, 16 years old, maybe. We got 80 feeders with it. We also got a reflow oven. So Chris has seen it. It's like a 14-foot long reflow oven. It has 7 temperature zones, the top and bottom. Each one's individually controlled, PLC controlled. It's got a nice, beautiful Windows 95 computer that came with it. And we also got a manual stencil printer. And so this is basically you load a stencil into it. And so it had squeegees and you could align it kind of with these knobs. We got all that delivered for $25,000.
The entire cost was that much?
The entire cost with delivery was $25,000.
Whoa, that's not bad.
That's not bad. And so because of that,
you'll pay more in electricity for the first year on the reflow.
And again, I would put that machine up. So it was a Japanese machine. This is actually the American version. It's called Zivatech, but Juki is still around. And we actually have a newer Juki I can tell you about. So that machine could place 0402s, no problem. And you could actually do 0201s with a special nozzle we never did on that machine. But everything we did was mostly 0402 size components for our resistors and caps and whatnot. And
so you started with 0402s.
We used to, because we kind of had to based on the size of
the
boards.
Right.
Because again, we're trying to differentiate ourselves. Everybody else was doing 0603s or 0805. So it's like, okay, how do we go smaller? Because again, that was kind of our claim to fame. So the machine could do it fine, and it had a boatload of feeders, and we got it super cheap. And again, the company that we got it from is a reputable company. So I wasn't just buying this off eBay, sight unseen. These guys gave support. But again, when it showed up, it was a 1996 machine, and with paper manuals that I spent many nights because I was still working full time at the time. So I was here to 2 or 3 at night reading manuals with loud music playing, and getting really excited when I got the head to move. and pick up a part. And it's probably a good month of tinkering with it. And again, it's a lot of fun, but again, it's not for the faint of heart. It was not just plug it in and now I'm making a board.
Right.
To really get that thing up and running. And then we obviously had to get electricity installed because the oven is a 483 phase beast. And all this kind of stuff even before we could start building the first boards. And so it was a huge learning curve, but even the worse, the bigger learning curve was then actually producing consistent product. Again, it's one thing you get it to place a few times and like, oh, this is cool. The machine's moving back and forth. But then when something screws up, which it commonly did, or the paste isn't perfectly aligned. And paste by far, this is a hard lesson learned. I don't know how much money I wasted on paste mistakes. Paste is by far the most critical step of the process. Use fresh paste. Always use fresh paste, and always make sure your stencil is really nicely aligned.
And that it's clean too.
Doesn't matter. Yeah, it doesn't matter how good your placement is. If the paste is no good, things just going to come out like crap.
Yeah. I was making boards for probably a solid 2 months where I kept getting like upset, like, man, these parts look like crap. Nothing's reflowing right. And then someone is like, do you want to just borrow my paste and see if it's any better? And I was like, and everything got better immediately. It was just like I was using like crusty old paste that I just should have thrown away. And
that's what I did too, because I was cheap. Because again, I'm like, I got this money, and it's like, paste is $50-$60 a jar.
Stitch in time will save 9, right?
And I'm like, I'm not throwing this paste away. I mean, this is expensive paste. But then you learn that lesson. Actually, about 5.5 years ago, we brought a guy on board, Dave, who runs our manufacturing operation now, that worked in industry, and he basically said, you can't be doing this. You got to use fresh paste every time. And we kind of learned that before, but when our yields, in the early days, our yields were about 40%, which is insanely low.
That's not great.
And that was, so what that would mean is, again, we have the small 32-pin Hirose connector, that there'd be a short or an open on that. Usually was the problem. And so
that is the basis of the entire system, we should say too.
So then we had to buy like an expensive soldering iron with a really fine tip and then have somebody rework boards, which is much more expensive than whatever I paid in paste. And after when Dave came on board, and actually it got quite a bit better in the meantime. We were not doing 40% that long. But Dave came on board. Now we're doing like 99% first pass. And of the things that fail, it's usually just like an open or something that we have to touch up that you can catch in, a 10-second inspection on a board. So it's insanely better. But again, it comes down to paste. We always use fresh paste. The good thing is our volumes are up considerably now, so we don't really waste a lot of paste. But if you're doing it at home, get fresh paste, or you can get them in cartridges now, which is really nice. And so it's not exposed to the air. You kind of push it out almost like a caulk gun. So it only dispenses the paste you need, and the rest of the paste is still kind of contained and not exposed to the air, which is the killer of it. Anyway,
as soon as that flux goes, it's trashed.
It's trashed. Just, don't bother using it. Just get new paste.
Yep. Wow. Okay. Well, have you upgraded to a automated paste system now, or?
Yeah, actually. So around that time, because again, that early stencil printer was so bad. Because you had to visually align it. The pressure was never good on it. It's just much easier just to hand stencil, which isn't that hard once you get the hang of it. But again,
it's inconsistent then between
it's
runs.
Inconsistent, and it's fine for like really small boards. But if you have bigger things and small QFNs, it's not great. Because again, a QFN, you do your pressure a little bit wrong. One pad's not going to get any paste or not much paste, and it's just not going to reflow. And those are a pain to rework. So we got a deck 265, and again, this was an older machine than our pick and place. So this I bought for $3,000 off eBay. Didn't know if it worked. It didn't work. Drove to Pittsburgh in a big truck, picked it up, drove it back, and ended up playing around with it. Again, kind of the same mentality. This is probably 6 months to a year after the original stuff. Got it kind of working, and then ended up paying a guy that used to be a deck engineer or deck field tech. He came up and kind of calibrated it and made it work, which was almost as much as what we paid for the machine, but is well worth it because we used that machine. Totally worth it. We still have it actually working. We used it today, but we just bought a brand new stencil printer because this thing, stencil printers, there's a lot of pneumatics in it, a lot of air. And so all these old tubes constantly break. And so you get a hiss and then something doesn't work, doesn't clamp down. And so we're constantly going in there doing surgery on the deck where you got to like cut out a piece of tubing and then, put a little coupler in there. So it's kind of a Frankenstein machine. No sides are on it. But again, it's worked for us for 5 years. But again, that was always our biggest risk, because if this thing really goes down hard, we're kind of screwed, because you can't just get a stencil printer next day installed.
Right.
So we bought
no Amazon Prime on that.
Yeah, no. So we bought a new machine actually in May, and we just got it installed. It's a Panasonic SP60. So it's so much better. Now we actually have it. So it's automated. So we have a conveyor system, whereas before we basically had to take it out of the deck and kind of like manually look at each board as it's pasted to make sure everything was good. And you also had to like manually wipe down the stencils, which is really painful and time consuming. So now the new machine has an under stencil wipe that works really nicely and just kind of, it's super cool. Again, then the nerd in me loves it because it's like this saves so much time and the paste quality is so much better when it prints. It's like, and we can do much smaller boards consistently now potentially. So we want to do 0201s and other things. The other big thing is we got a new pick and place about 2 years ago. So again, it's from Juki, but this machine is less than 10 years old when we got it. So to us, that's a very new machine. But it can do like 13,000 placements an hour, can do BGAs, very fine BGAs. It can go down to 01, 05 components, which we're not doing. It's crazy, but it's a super sweet machine too. Much faster, much better than the old one. The old one, was getting a little long in the tooth. It started to break down a lot. New machine's much better. And so basically we've kind of improved our line incrementally. But now, I mean, the machines are kind of so advanced and so fast. Like to do one of our panels, a typical panel that we make for our products is usually like 30 boards on a panel that's about 6.5 by 6.5 inches. Maybe takes 3 or 4 minutes to go through the pick and place. If it's like something that's got like 600 components on the total panel, right, which is really kind of cool.
So do you have to start to do like calculations now on like when you were deciding to buy this new machine then too? Like, so first off, I think it's amazing. You're just you started an electronics company, right? But then you became a manufacturer, right? That's very interesting to me, and maybe a cautionary tale. I'll get your take on that in a bit. But like, do you start to calculate now like utilization rates and all that stuff, and like return on investment of the actual of buying the machine and like the capital cost of it?
In a way, we do in terms of the ROI on the machine. The one nice thing is it keeps extremely good statistics about placements and whatnot. So that's always kind of cool as the tech geek to see, okay, how many it actually placed. I think the bigger thing is enables us as a business to kind of do things that we couldn't do otherwise. We can do extremely small runs or big runs of different things. And we don't have to worry about that outside expense. Again, if going to a contract manufacturer, we can kind of do, things on the fly, and it lets us kind of test out all sorts of different products that, again, might not take off. But if we were to have to pay an outside CM to build up 100 or 1,000 something, it'd just be cost prohibitive because, again, I guess we're kind of past the startup stage, but we don't have any outside funding. Right. It's basically just myself as a sole owner. And so all our monies come from sales because essentially Kickstarters are sales. And so we've kind of grown organically that way. And again, I kind of look at like Adafruit or SparkFun as kind of, I guess, setting the road for that because again, that's how they did it. And so that was always kind of my mindset about how do we do this without having to raise money. And there were certainly some times where we considered it and we had some interest. Certainly glad we didn't. And, but yeah, the manufacturing capabilities, although it was extremely painful in those early days, I think it's definitely paid off in terms of I don't have an actual number amount I can say, but I don't think we'd exist if we didn't have that capability today. Yeah,
it makes you wonder. Well, so like, I mean, I think about my prototyping, right? Maybe not at the 100, 200 like you're talking about, but like I could pay to send it out or I could do it myself, and there's like all of these curves that kind of cross over at some point of like when should you send it out to a CM? When should you keep it in-house and do it yourself? When should, it's like these weird calculations. And I think in my case, I'm just always defaulting to doing it myself.
Well, the thing is, it's gotten much cheaper to send it out because, again, there's
true
these online services, and again, it comes down to printed circuit boards too. At least back when I was Avid, we'd always go with these places, and you order a circuit board, and it's like, okay, we're paying $500. That's just what you pay for a circuit board to get 5 circuit boards.
Look at you, advanced assembly, advanced circuits rather.
Yeah, advanced circuits or Sierra circuit, all these different places. Man. And that's just what you would pay. And we do that for our customers. I'm like, okay, we're buying a circuit board, no matter how simple it is.
Right.
It's,
just
we're going to budget like $750 for that.
Yep.
Now you can get that same board for $5, and get 10, for these things from China, which is crazy cheap. It's going to change things. But now a lot of these services too offer assembly, whether it's Advanced Assembly or someplace Screaming Circuits in the US to a lot of these places overseas. It's gotten very competitive. And so now you can do small runs, get them assembled. And I know a number of people have done it successfully and have had good results. I think, does Oshpark do it now? Did they team up with somebody, Advanced Assembly or someone?
Not that I know of.
Okay.
But there's, like a lot of the Chinese board houses, they all have assembly. And like you said, I mean, and then there's all the online ones like Macrofab and Circuit Hub and PCBNG got bought. I don't know what's up with them.
And so maybe if those existed back 6-7 years ago, or maybe if I knew about them, if they did exist, I would have gone about things a little differently. But
but then maybe you would have changed the product mix too, right? So that's the other interesting thing is that like you might not have gone as wide or as it'd
probably be much narrower. Yeah, because again, those low volume things. Because we did on the first one, we did an Ethernet shield, which was a bit crazy. And that we maybe made 50 of them. That was a huge pain in the ass. We discontinued that because again, with this side of the platform, it doesn't really make sense. We kind of learned Wi-Fi and wireless is what people want, and it just was insanely drew a lot of power. It's just pain.
Right. Well, I think it's interesting too about like it is kind of like you said, like your contemporaries are Adafruit and SparkFun. Maybe they're like slightly larger scale, but like it's making breakout boards effectively, and you can do that in a cost-effective way.
Exactly, and they kind of show that because again, when I was starting this originally, SparkFun was kind of the big guys out there, at least in this world. I think Adafruit at the time was a little bit smaller, and then I think they've probably overtaken them now.
I think it's inverted.
But again, if you follow the paths of what they've done, they did that exact same thing. And again, I think you were there at the Open Hardware Summit. We took a tour of SparkFun, which is kind of cool to see their line. Mm-hmm. And actually, the shocking thing was, I was there with Ben Rose, kind of our lead engineer. We were kind of shocked at how small their line was, or it's kind of crammed in this back little space. I'm like, I think our line is actually bigger than this line space now. Yeah, so we actually have more. I think they ship more product. I would guess they ship a little more product than we do, but it was kind of cool to see just how they came up, and also they've been very forthcoming with, and so is Adafruit, with just sharing what machines they've bought over the time, what mistakes they've made, and again, that was kind of just some encouragement that hey, this can be done, so why not try it?
Right. Well, and so that's an interesting comparison too, because I would say that the SparkFuns and Adafruits of the world, they fund themselves through manufacturing, but their main product is actually IP based. Mm-hmm. And it's tutorials and it's knowledge and it's basically stuff that generates online clicks and stuff like that. Not saying they're clickbaity. I'm saying that they do so much content based stuff that it draws people to their sites, and that's what their real product is.
Exactly. Yeah. I agree with that too. I think SparkFun too is more of a distributor as well in terms of they sell a lot of other product as well.
Right. Yeah. That's a good point.
But no, I definitely agree with that. And it's probably one place we're not as good as them by far.
Well, and what's interesting about that is that you actually ended up doing some CME type work as well.
Exactly.
And so how did that then balance against doing stuff yourself versus doing stuff for other people?
Yeah, so I like to say we're not a CM, but we've done quite a bit.
Unless you pay a lot of money,
or it's got to be the right mix. So I like to tell people because again, we're not. If you look at the kind of the contract manufacturing landscape for electronics, you kind of have in the U.S. you have you have all these shops that are basically focused on we have all these standards in place. We're ISO, we do these military aerospace type specs and whatnot, and certain quality things. We're kind of a maker mindset here. Again, I think so much like an Adafruit or SparkFun. So, we don't have ISO 9001 for our processes and things. We're kind of a small little startup, scrappy place. So we try to shy away, depending on the customer. Like say, this is, I think we can make it, but again, we're not that kind of shop, and it's super competitive too. So it's like, do we want to be a CM where you're fighting for every little penny? And once the volumes get up, it's just going to go overseas anyway.
Right.
Because again,
yes, that is very true.
And
that is, I've seen that happen many times.
Yeah. And so we know a lot of CMs in this area, and I refer people to them if they have a particular need. Where it does make sense, and what we've done in the past is, again, people use our product or they come to us and they want something custom designed. And we, again, tend to shy away from that unless it makes a lot of sense for us. Because, again, we have a very small engineering team. Again, I'm an engineer, but I don't do a lot of engineering anymore. So it's typically Ben. It's kind of our main engineer. And we have a new engineer that just came on that was an intern with us. Raina just came on in May. But it's a pretty small engineering team. So if we take people off to do like consulting work, which we have done a lot of, because again, it kind of kept us afloat for a number of years, it takes away from our own product. But in the case where we do contract manufacturing, generally it's with a customer that has something that fits in well with the mix that we do. So maybe they've done something with our standard product line, and they say, hey, we want a custom board where we put Bluetooth Low Energy on there, a processor, and some sensors, and we want to order 1,000 of these. I'm like, okay, we can do that, because again, that's similar to what we do anyway. But if it's somebody who just comes to us with a design,
right, you're not doing the napkin service like Avid used to do.
No, not at all. Because again, we just don't have the staff to do it. That being said, we've done a number of these custom type things, and a number of them have worked out well. We're actually doing a huge one and it's not a tiny device at all. It's a robotic golf caddy, which is kind of cool.
Oh, wow. Okay.
This is something I worked on at Avid, and it's followed me here, and now it's actually in production. So we're actually manufacturing the electronics for it. So it's basically the idea of it. It's out on the market now. I think it's all public. I can share it. It's called the Club Car. Club Car is the biggest golf cart manufacturer in the U.S. Or in the world. Yeah. And they basically have rights to this product. It's called the Club Car Tempo Walk. But basically, this is an autonomous golf caddy that follows behind you. You can Google.
Do you like working
you
out in golf while golfing, but not really? You don't want to carry your bag, but you still want to walk a little bit.
It's exactly the angle it's going for. If you look at golf, there tends to be older people that play golf, and a lot of them can't walk with their bag, and so they're forced to use a cart. So that's kind of the mindset. And again, this is not something you'd own yourself. You'd rent it at a golf course.
What happens
anyway,
so it's. But does it have the same services that like Rodney Dangerfield would look for in Caddyshack?
It does have a cooler. I mean,
beer dispenser. Nice.
Yeah,
okay,
it has a tablet on it, so you can order stuff from the clubhouse potentially. But the idea is basically you wear a small wireless transmitter in your back, and this thing just follows behind you. So I personally was involved in this development back at Avid, and then it continued at Avid for a number of years. And then basically all the people that worked on it were no longer there. And so they end up calling here. And it says after my, conflict of interest period was over with Avid.
Right.
And so kind of worked on some stuff. So it's using an ultra wideband wireless system now. And the cool thing is we're doing the manufacturing for the electronics here. And if it takes off, and actually it's doing really well right now, that the revenue from that, just the CM work of that, is more than the rest of the business.
Right, it pays for tiny circuits.
And so the great thing is it gives us this nice revenue stream, kind of a completely side stream. And again, we designed the board so it fits in well with our manufacturing process. And
you gotta watch out, man. That's a dangerous drug to be.
I know,
direct line into the veins. I've seen startups go belly up because they've got one big customer. Man,
that is a fear, and so there's that. But the nice thing is it complements the rest of the business. So right now we're not living on any of that revenue.
That's good. Yeah.
Granted, we got paid design fees to work on the design, but the manufacturing again complements that. And the nice thing is it allowed us to get newer manufacturing equipment that then we can use for tiny circuit stuff. And so now we can do smaller things that we couldn't do before. We can do O201s very reliably. We could potentially do O105s, which would be crazy, I say. I'm not sure we're going to get to that.
How tiny can tiny?
Exactly.
I mean,
there's actually smaller ones than that now too.
But I know.
Again, at some point, it doesn't make sense because changing the size of your resistors doesn't really save you too much at some point.
Right. What are your customers asking for? I mean, so you've obviously had a lot of customers. You're doing a lot of things. Mm-hmm. What are they asking for?
I'd say probably the number one thing we get requests for. It's kind of like in the IoT space, so cellular. and I know you got some experience in that.
I do.
And so
the tough thing is those modems are still monsters.
Yeah, it is a problem. And generally, we point people to Adafruit, use the Fona. And you can hook it up to our stuff.
And the Fona uses a 2G modem, which is, the SIM 800. That thing's going away, though.
Yeah, I know. And so we actually designed a SIM 800 board. It just didn't make sense at the time to do it. We've designed probably 30 different boards of different things that we just have never released because, again, it's from the business standpoint that the design usually is
you got to sell. You have to sell a certain number. Yeah,
I like to say too, because Ben does pretty much all our electronics designs. The design of any of our boards is almost trivial in terms of it's a couple hours to design.
I mean, give Ben some credit, man.
No, I give Ben. Ben's a genius. But again, we put a sensor down on a board. And that's why people too, when they talk about open source, like, isn't somebody going to steal your idea? I'm like, any engineer could reverse engineer this in 10 seconds. There's nothing
special
here.
You're stealing my 5 hours.
Yeah,
right.
It's more about the manufacturing and the marketing and the tutorials and all those sorts of things. That's really where the time comes in and the expense really comes in. So cellular is something we want to do. Definitely IoT is a big focus. And so this new product line we have is really geared at making it easy to connect up different sensors and whatnot. And so
segue.
Exactly. So the roadmap forward for our main product line is higher end stuff. Because again, we've got all these boards and we've had our Arduino system for a while. We're somewhat stagnant for a couple years. And again, that goes back to, this like Golf Caddy product and different things where we basically took on a lot of consulting jobs to, again, pay the bills. So myself, my time and Ben's time, a lot of that we're getting paid hourly to do other projects. And while it kept the lights on, it really again, stagnated our product development. So we had, again, these products we're calling Whiskers now. The first ones we had 3 years ago. And again, they're relatively simple. It's like, okay, we need to have a whole platform and we need to do these tutorials. And really at that point, we're like looking at our old tutorials. We have interns over the years for 5 years. Everybody's different. It's like, let's just revamp all that. And so last year we got a number of interns. Actually, Rainer, who just came on full time, kind of manages the interns now. And so we have a new wiki out. So we redid every tutorial that we have for the platform and also kind of geared for the future too. So not just our original, Tiny Arduino, which is kind of an Uno type processor. Now it's Zero and potentially with the new Whisker platform, also Pies using CircuitPython and different things. So kind of looking to the future and, revamping everything.
That's great. So what is the Whisker thing? So this is what's on Kickstarter.
Exactly. This is what's on Kickstarter right now. So this is essentially, and again, the idea isn't new. It's we're connecting sensors via cabling. So, but the difference is these are much smaller. So there's other things out there like SparkFun Quick. You mentioned something from Adafruit. There's a new platform. The big one out there is the C2 Grove system, which is very similar.
Sure.
So that's same.
Grove's a little different because they do. The Quick is it's I2C only.
Yeah.
And it's only I think it's only a 4-pin connector, so they don't have.
Yeah, Grove can be different things.
Grove can be analog, digital. I always thought that was kind of weird too, because what happens if you plug into the wrong thing? But most of the time, it's not a problem. I think they do analog, digital, serial, and I2C.
Yeah. So in this case, basically, it's a 5-pin connector. So we've got 3.3 volts in ground, and then also I2C and an extra pin, which can be an analog input or it can be a digital pin. And actually, the I2C can be driven digital as well. But the nice thing with it, like the I2C, so all our breakout boards for this have a MUX on there. So you potentially, if you have, let's say, a 9-axis sensor, an accelerometer, or something that is on some set I2C address, you can actually use 4, or actually in our case, like up to 16 of all these things on the exact same address. Because then again, there's a MUX to select which one you're talking to.
That's nice.
And also, again, it's not just I2C, so you can do much simpler things. So like a push button. So again, if you're making, let's say, an arcade cabinet, you can wire out a small joystick or a push button. Actually, more in the case of like a push button. So it's just a digital input that can go to an interrupt on your micro. So again, you don't have to have a processor in that overhead of doing the I2C communication. But we've got like 35 different boards out for it. Again, most typical type sensors, whether it's barometric pressure, 9-axis, color sensors, then output devices like little vibrating motors, LRAs, buzzers, all sorts of fun stuff, and a lot of little screens too. So the cool thing is, like, we've got these little I2C screens. So like a 0.42 inch screen, up to like a 0.95-inch screen. And so you can kind of add these things really easily to your project. And again, the other thing that we kind of, because again, our main product, the Tiny Duino, these stackable boards, it's kind of a niche type product. So we tried to expand this beyond that. So that's why we have a Pi hat for it as well, or just a standard Arduino Shield. So you're not just stuck into this. And the other thing is it's just I2C, so you can easily hook up to anything if you want to.
Right.
And it just uses a small JST SH type connector. So it's a nice small connector. The cables are super cheap. And it's just
how much are the cables? Because I always feel like that's the hidden cost of a lot of these.
Yeah, we're going to be selling them for like 99 cents.
That's great. Okay.
And then the other thing too is, at least with the Kickstarter and different things, we kind of see you probably want to get a kit and you can certainly get an individual sensor. And the nice thing is too, they're like super cheap. That some of the things will be just a couple bucks. Because again, that's one of the things we always run into is like people go on eBay and get these little Chinese things, and for $1 or $2, it's like, well, we can't really compete with that. But so with this new form factor, we can somewhat compete with that and maybe offer some benefits, opposed to just some little breakout boards you get on eBay for 99 cents.
And how do they even do that?
I don't know how they do it.
Logistics
again,
of
some
one
third
person
party is
touching
selling
it.
Yeah,
exactly. Someone's making money. It just feels like it must be bought in bulk and they're just already prepackaged or something. I don't know.
And then actually, you met him. We share space with a drone company. He just got a 3D printer. I think Creality or Creality.
The $200 one. Yeah,
he didn't get the two. He got a $600 one, and this thing prints amazingly well. Like we were setting it up the other day, and it set up in 10 minutes, and we're like, how? I don't understand how it's possible. Because again,
China.
they have
China
these much.
Just great,
China
man.
is
like
insane.
They're just really killing it these days,
Yeah. So until we just tariff them to death here in the U.S. at least.
Well, that's
different
issues.
That's actually something we run into too, because we do.
Yeah. Oh, let's hear about it.
We source a lot of stuff from overseas. I mean, electronic components aren't made in the U.S. You don't buy capacitors or ICs that are. Well, I guess there's
you're not
a few
buying
ICs.
In small amounts either.
And so
you're not underneath the cap, right?
Yeah, and so we buy a lot of stuff, and I mean, we typically buy from U.S. distributors, so Arrow or DigiKey or Mouser and whatnot, but they add the tariff charges on there,
right?
And so we do get hit with that, and it kind of ticked me off when there were tariffs on like raw components, but not on finished goods. So it's actually cheaper if you manufacture it all in China, and then you can sell, ship the final iPhone. And there's no tariffs associated with that. But if you import those raw materials and manufacture here in the U.S., it's actually 25% or whatever it is.
Right.
So then there's
definitely
other
good for manufacturing, right?
Yeah. So because people, some people came up to me and say, "Oh, this has got to be great for you. You manufacture electronics in the U.S." I'm like, "Well, no, because all the raw material, a good chunk of the raw materials come from over there." And so, I mean, that's biting us in some other areas. So like the cables. We have basically a Chinese company we're working with, so we're getting a bunch of these cables made custom. But again, they're in China, so we'll get hit with a ding there. Again, luckily the cables, when we buy thousands of them, they're not too bad. So but then we buy a lot of batteries too. So we actually one of the biggest things we resell are lithium batteries, and it's actually doing really well. Oh yeah, we sell lithium batteries on DigiKey and Mouser. And that is by far the biggest thing we sell on DigiKey and Mouser. And so
I will say, I was looking for 18650s, and I was like, where the hell do I buy these things?
We sell 18650s.
I went on DigiKey, and I ended up buying it from SparkFun, but I didn't see yours on there. But I have seen that you're. Sorry, man, I didn't see it at the time. But like that's crazy, right? That's why is that happening? Is it because people aren't willing to take on the risk or something? I don't get it.
In terms of buying directly from China?
Well, no. Like, why? I can't buy them on Amazon.
Oh,
well, you can buy them like battery for vaping device or
for
whatever, right? But like,
I'm not
there's
sure,
not
because
like
again, it's the same lithium battery regulations shipping, because there are a number of regulations for shipping.
Sure. You can't airship them and stuff like that.
But again, it's not really any different with 18650s. So we found the 18650s, because we sell on eBay and other places too. 18650s are the number one thing we sell on eBay.
Really?
We sell, I'd say on a given day, between 5 and 10 18650s, which isn't huge volumes. But again, we just put it up there.
Sure.
We weren't trying to sell them necessarily. It's just we're connecting with eBay, and we list products on there. And again, they're like usually like a onesie twosie type orders.
Sure.
But then,
and it's people probably for products and maybe
I think
for
those are
vaping
mostly
or whatever.
hobbyists or whatnot, or vapors.
Yeah.
But then, the people that buy on a DigiKey or Mauser, they tend to usually buy more. So yeah, we're buying a lot of 18650s and importing them. And paying tariffs on them as well. But yeah, so the nice thing about that is, we certainly have the DigiKeys and the Mausers and just our own customers, because we use these batteries in a lot of things. And so we're buying a lot of batteries at a time. And it's expensive to ship them and all that from China. But then, once they're in the US, because again, overseas shipping of batteries is a little tricky. And actually we have people that reach out to us to say, hey, I used your battery from Mauser and I want to, buy more.
Who's your supplier?
They basically say, they say, I saw this on Mauser. I can't get it because they won't ship to my country. Can you ship it here? I'm like, well, if Mauser or DigiKey's not shipping there, guess what? There's a reason. That there's all sorts of restrictions. So a lot of times these people say, hey, I want to buy like 100 of these or 500 of these. I'm like, I'll look into it. And it's usually not pretty, because actually some countries you can't ship them to. Others you pay exorbitant fees with FedEx or UPS to ship. But it's actually worked out pretty well.
So you thought you were becoming a manufacturer, but now you're just a battery import-export.
Exactly. That's I'm kind of learning from SparkFun, reselling. And the great thing about them is
Battery Depot.
You don't have to manufacture. We just put them on the shelves, and they're just there, and they just go off the shelves. It's great.
That's right. That's right.
So yeah, I mean that's potentially
you're like a new Radio Shack. Didn't they end up just being a battery
club.
Sales at the end?
Well, wasn't there like a little punch card you could come in and get a free battery?
I think so. Yeah.
No, so that's kind of we've looked into reselling more stuff. It's kind of a little complicated because again, if we sell it, we want to make sure that it's good. So at least with the batteries, we're working with. Right. One particular battery manufacturer, we've worked with them for like 6-7 years, and we've bought I don't even know how many batteries, way over 10,000. God, probably 25K plus batteries, maybe over 50K batteries from these guys, and they've worked out really well. And so we have like 10 different variations and use them in like little arcade products or just with our kits or whatnot. So. But if we're to resell other things, it's kind of that same thing that we've done some on eBay. It hasn't really worked out great because again, a lot of these products aren't really things that make sense to sell on our own website because we're not like a resale website. So we'll buy motors or different things, but then you buy them on AliExpress, and next time you buy it, it's not the same thing. So it's like, okay, how do we guarantee that consistency?
You need like a QA manager. At that
so
point,
it's worked out well for batteries because again, we have one point of contact, and we've worked with them a long time and know their quality, and also can purchase in big enough quantities that then we can go back and say, hey, we need to purchase 5,000 more of this particular battery, and they usually respond quickly. So that's pretty cool.
Yeah, that's good. Mm-hmm. That's good. What about the so I think you're pointing out the fact that there's the retail side of all this as well. I mean, any cautionary tales in there as well, and aside from the manufacturing
in terms of selling retail?
Or I mean, I guess you're going through distribution now too, so that's the other thing. So and I love to say that you guys sell at Micro Center, which I think is awesome. I love Micro Center.
We do.
Not every place in the States has it, but
no, we sell at Micro Center and we sell at Fry's
for now. Is it Fry's closing down? Sorry.
I've heard conflicting things. Actually, I talked earlier with Fry's.
Okay, good. Well, we hope for the best. How about that? We hope for
Fry's are cool.
A swift recovery. I don't want Fry's to shut down. I want Micro Center. No. That's
Micro Center is much easier to work with. I'll just say that. I'll put it that way.
Okay.
Because I want to. But yes, so we sell retail. Our products really aren't geared at like in-store type retail. Again, because there's a bunch of development boards and whatnot. We do have some kits that sell a little bit better retail, but online distribution. So DigiKey and Mauser have worked out really well for us. I think one of the big things that gains us is some credibility. Again, is the engineer in me. We got DigiKey, now although we got Mauser before, I love Mauser. But when I was at Avid and other places, we just would always go to DigiKey was the place you go to, and
Right. Well, you mentioned like the idea of these systems being prototyping tools as well. And like when I think about I start a project, I'm usually going to an online distributor and I'm like, what's here? What can I use? And then if it gets listed,
what's there,
Well, and like, so now I search for a sensor. I search for BMA 680 or whatever, the sensor might be. And it's not just the sensor anymore. It's the dev boards that pop up too. And then I discover new platforms like this.
Yeah. And they've been making huge inroads into kind of that whole maker thing. And they're definitely committed to it. Like whenever we release a new product, they're like, hey, we want to list this as soon as possible. And yeah, you go there and we search on things, and I buy a lot of Adafruit stuff from DigiKey. Because again, I buy so much DigiKey stuff. I mean, I don't want to say how much money we spend at DigiKey, but it's obscene. Because again, we get a lot of and
I'm sure many distributors too. get your
really? I was gonna say so let's just say we buy a lot more from DigiKey than they sell. I'd like it to be the other way, but I mean realistically. But yeah, so I'll go on there, I search on something, and I'm like, oh, this is from Adafruit. I trust them. I'll buy this. I just added my cart because I got a million other things. So I don't even go to Adafruit's site necessarily, or SparkFun or wherever, because all these guys sell on Mouser and DigiKey as well. So again, just to have our product show up there is like, okay, we have this stamp of approval that we're not just a little garage shop anymore. That okay, these guys have vetted us. They trust us. We've been on both sites for like 2 years now. So obviously, if we were really screwing things up, they would pull us off very quickly because they have very reputable names to maintain. So again, I think it just helps too with our overall sales that we can say, hey, this product is kind of backed by these big names. They trust us. So that was kind of a nice leap to go sure from.
It's better exposure too, right? I mean, you get more eyeballs that you wouldn't of different types of people, right? Not makers necessarily.
Yeah, so more the engineers. And I think too. I mean, the maker market, frankly, for us is somewhat stagnated, if not gone down. So the question is, and I think that's across the board. I've heard that from other people as well. I mean, you can certainly look at Maker Media and things like that, but
they've had some days. Yeah. I'd be interested in the software mix too. Like when I think about platforms like this too, it seems like it's like perfectly set towards people that are like, well, how about I look at Adafruit's platform and I think about their stuff, the MicroPython stuff.
Circuit
I think
Python.
That's brilliant. From Circuit
that's
Python.
What they call it. Yes.
But like it's brilliant from a targeting not just beginners. I think it's good for beginners, but then software people coming into hardware. Yeah. I always talk about software people coming into hardware. I think a lot of our listeners are that too. And these kind of platforms are just like, they're just tools to prototype, but then prototype from a software perspective too. And that really helps too.
Yeah, I remember, I forget how many years ago, there's something called Johnny 5. I've heard of that. It's like Node on an Arduino.
Yep. And Fermata.
Fermata.
Jason Huggins.
And so like somebody contacted me about, if our stuff supported that. So I look more into it, and I'm like following these online communities. I'm like, what is it? I don't, again, I'm the embedded guy. I'm like, you have to be like tethered to a computer and you're using Node and JavaScript and all this stuff. Right. Like, why didn't you use C? I mean, it's so much easier. But then I see they have these like Node bot meetups in New York City with like 30 or 40 developers. I'm like, oh, yes, it's what they're used to. And it's getting them into embedded stuff. And then
exactly. Yep.
Again, with the embedded guy in me, I'm like, well, just use C. I mean, it just seems to make more sense. But again, you gotta have to go where the market is. And again, thinking what these maker type things are, they're generally geared at those newbie types that aren't necessarily engineers, that might not have experience. And so I think CircuitPython's great. That's actually, we've talked with people from Adafruit a number of times at mostly like the Open Hardware Summit, where they say, hey, we want other people to develop with CircuitPython. And so our latest stuff now supports CircuitPython. So again, it's all SAMD
great.
Stuff. And we don't have a lot of it published yet. So that's something we had basically an intern working on that. And then also CircuitPython on like a Raspberry Pi or potentially like a BeagleBone, but or BeagleBoard. So we're doing Pi right now because we have this new Pi hat. But I think CircuitPython just offers a lot of ease of use, especially in like educational environments where you now don't have the Arduino IDE you have to download and install these drivers. It just pops up as a USB drive and you just copy your file over to it. And that's always, let's say, software questions like installation and COM ports are like number one questions you get. And it's like, okay, these are very basic things. If you can eliminate that, you kind of open it up. And I think people get frustrated by that too. It's like, I plug this thing in and it doesn't work. I can't see the COM port. It just downloads and says, 10 different errors, whatever they say in the Arduino IDE, like STK 500 error. I get way too many of those emails. It just has this long error string. Like, you really should simplify that and just say, hey, it's not working. Check your COM port. But I think the software stuff is kind of key. So making it easier to use. We've done some work too. A lot of people talk about our stuff in education. Actually, a lot of people mix this up with Little Bits, although I think they raised a little bit more money. They just got sold. I think they spent a little bit more money than we did too.
They raised a lot of money, and they got. I don't think they got bought for as much as they raised.
No, I'm super curious to know. I'm just again because again they kind of had a similar trajectory in terms of time. Because again they were a very small startup early on, and then we'd always get that too about because there's similar names like, oh, do you guys do this magnetic thing? I'm like, no, that's not us.
But, which was a great connector. I always thought that idea was really cool. But then
it's a great idea.
The cost per board was tough too, right? That's what I think was tough about their
selling price. It was that, and now there's a number of clones or similar things, and then also,
sure, yeah.
Again, we haven't raised money, but I don't know what you can do with $60 million. I mean, that's a lot of money. I think isn't that what they ended up raising over the?
You said 60?
Yes. The last round was like 45 million. I think they raised like 15 before that.
Oh my! I didn't know that.
Oh no, it's insanely high. And then I'm like, I got to buy toilet paper this month. Hopefully, I got enough money to do that.
The life of a manufacturer.
But again, I'd say it's worked out fairly well. So we're in a much better place now.
That's good.
Again, I'm not sure why we're on this tangent, but little bits. But
I think just because of
software,
sensors, and
I was saying like education. Yeah, so education is somewhere where we do want to go. I think there's some growth things, and so we've kind of teamed up with other people. We're actually working with a group out of MIT. You might have run across actually the Maker Health group. They're usually at Maker fairs.
I've never seen them, but
they're doing a small robotics platform, and so they're using our stuff. But again, it's geared at like middle school and high schools. So the cool thing is we're kind of again leveraging a much better name. Well, was better until the Media Lab stuff last week. But this is not Media Lab we're dealing with. But so potentially I think there's some opportunities to take our stuff into education and other things kind of outside the maker realm. But then selling to engineers and selling more than just onesie, twosie pieces is really where we want to go. And so kind of these like IoT prototyping platforms. So if we had more cellular or different, like more integrated BLE type technologies is kind of where we're going. So like basically little BLE processor boards you can connect up sensors to really easily. That's relatively low cost. And so you could prototype something in 50 or 100 pieces and get that through a DigiKey or Mouser instead of having to design your own circuit board. Same with like cellular and these different sorts of things. We'd really like to sell more into that. And so that's kind of one of our main focuses after this product line is, higher end boards. How can we set ourselves apart from some other people, small, tiny little things and also better software support. So things like CircuitPython and like that, just to make it, again, easier for other types of people to use these.
Yeah, I think you're talking about like value add in general.
Exactly.
And
I think that's the only way you can kind of compete.
Thing,
It's really the only way you can compete. And again, like you say, SparkFun and Adafruit kind of compete with content. Because again, you can go on eBay and buy super cheap Arduino clones for really
you can buy
a
clone of an Adafruit thing too, but like I choose not to.
Exactly, and I think a lot of people do that. And hopefully that continues, and people continue to come out with really cool stuff.
Yeah, that's great. Mm-hmm. That's great. Well, where can people find out more about you and your business and your Kickstarter?
Well, the number one place is at tinycircus.com, and Kickstarter's on Kickstarter, but if you go to tinycircus.com, you can click right through. It's kind of right on the main page. And so, the Kickstarter started just a few days ago. We've been funded already, but again, we'd like to get more to be able to make a lot more cool stuff. And so
if we hit the stretch goals here, folks,
it's the stretch goals.
Ken will buy a second pick and place line and stack it directly on top of the first pick and place line.
It will be a double decker pick and place line. I don't think it's ever been done, but we will do it.
Never been done before.
We do have our old machine. We can, and we've got enough headroom. We could stack it on top.
You should auction it off. You should say there's an auction. If you back the Kickstarter, you get a raffle ticket
for a pick and place machine.
Pick and place machine. It'll show up on your loading dock.
I don't want to say we actually have multiple pick and place machines we could do that with, because
you could start your own you could start your own manufacturing company. Ken will come to your house and teach you how to do manufacturing.
I don't know if I'm going through that again.
You can move to Northeast Ohio and
you would
get
have
an
to
office
move
right
here
next to Ken and learn about manufacturing.
Actually, one cool thing is the Akron Makerspace just moved into our floor.
Great.
So that's actually kind of where I shared early ideas, was like at the very first Makerspace meetings. And so,
we should say that real quick too. We said that at the beginning. You guys are in an old
rubber factory.
Goodyear plant.
It's Goodrich.
What is it?
Goodrich. So Akron in its heyday was kind of the world center of rubber.
The rubber capital of the world.
Capital of the world. And so there were 4 major rubber companies here. So Goodyear, Goodrich, Firestone, and I should know this, General Tire. And they all had these huge factories. And actually, the Firestone factory is still here. They have some Bridgestone research area. Goodyear is still headquartered here, but Goodrich moved out completely. And so they actually, the place I'm at used to be the largest rubber factory in the world at 3 million square feet of floor space.
Oh, it is an amazing building, and it's
huge.
So old.
Yeah. So the actual building and so it was actually 70 different buildings. And in the 80s, Goodrich moved out, and actually they stopped making tires here a while before. But that building we're actually in was making like space shuttle tires and aircraft tires at the very end.
Yeah.
And then obviously those jobs left, and actually all the tire manufacturing left as well. So I think the city smells better now. I hear it used to smell really quite bad. Yeah, so the facility we're in, a lot of it's been renovated. Actually, probably 2/3 of it has been torn down. So there's still 1 million square feet of space. And then there's like an office side. There's a business incubator here by the city of Akron called Bounce. Great name. And then the rest of it's privately owned. So we're in kind of the privately owned side. And so we rent space. We've got 7,000 square feet of space here. It's relatively cheap. It's kind of, we're up on the 5th floor. Yeah. It's really good. There's a roller rink above us. There's 2 breweries. You need to come back. There's 2 breweries now.
Oh man!
In our building and restaurants.
I'm more interested in the roller rink these days, but yeah, that's still pretty fun.
Yeah. So it's just a roller derby.
That's cool.
You'll get. I've seen you. You'll get your ass kicked if you go up there. I would too.
Yeah,
so
totally.
Yeah. So it's a really cool building that we're in, and there's like artists and bands and people like that in here.
That's awesome.
But it's, again, for us, we share space with a drone company called Event 38, and then. Like this summer we had 18 people in here for us, and they had like 6 or 7 people. And so it's really kind of a cool environment, very startup feely. And again, we're kind of,
that's right. Bring the Silicon Valley to exactly, Ohio.
Right?
You need to go there.
And again, we can make stuff here. We don't have to pay insane rents like you'd have to in Silicon Valley.
That's right. Yeah.
I remember talking with Jeff from, do you know Tempo Automation? They raised a bunch of money.
Of
Jeff used to come to a bunch of maker fairs. He was doing a pick and place early on. I remember seeing that. He was doing like his own pick and place and kind of pivoted and is doing quite well. Doing a CM service, like a premium CM service in the Bay Area.
That's right.
But I remember talking with him when he first rented space. He says an hour outside San Francisco, 1,000 square feet of space was $5,000. And he says it's in a dumpy place. I'm like,
yeah.
Our rent is less than a 5x that, and we have 7,000 square feet. Granted, it's a rough space, but it works out well for us, and so that's why we can do it here in Ohio.
That's great, man. Yeah, oh, that's good. I will say, I remember the first time I went to Akron. I was visiting a college place down there, and I remember they had a rubber tree in the courtyard of this building, and I'm just looking at them like, this is the most out of place thing I've ever seen.
Isn't that some fraternity down here?
I think that was okay. A rubber tree in the middle of Ohio would not make it. So
I've heard. I haven't seen that, but I've heard of it. Yeah, but no.
Yeah, I've seen it.
Tires are the big thing around here, or were.
That's right.
So
we're.
But the cool thing is, there's all this old space here. So like Goodyear is being renovated. So they're still headquartered here, but the old factories, there's like new apartment buildings, and so it's kind of cool to see the whole area is actually kind of rebounding. Which is so you'll have to come back, Chris. You'll move back.
I will. Okay. All right. Well, until then, Ken, we'll talk to you soon.
All right. Thanks, Chris. Great talking with you.